César Verdejo speaking from Corporation. I'm here to introduce you to one breakthrough innovation from Fluke, once again. In this case, our acoustic imager Fluke II 900. Sorry. It's not moving. Okay, thank you. All right, so compressed air is pretty much everywhere. Any single facility, any single manufacturing site has its own compressor system, apart from other gases, vacuum systems that need to be maintained as usual. The traditional way of doing that has been very, very traditional, and it's been basically having a walk during weekends when the manufacturing floor is not working to hear the noise that the compressed air system is generating. So the maintenance manager, maintenance technician basically had to go to the factory on Saturday, Sunday, have a walk along the factory and hear where the air leaks are coming from, identify them, and then hopefully in the coming weeks fix them. No technology involved, anything else. So Fluke released this new technology, which is using ultrasonic sound detection to detect leaks and locate them, and not only locate them, but also evaluate its severity and document it while the factory is working. No need to stop production, no need to go during the weekends to maintain your system. That's no longer the case with our new unit. I don't know if you know that, but a single 3 millimeter leak of compressed air can cost you up to 6,000 euros a year. That's a lot, really a lot. So maintenance technicians and maintenance managers know that and need to take measures to maintain their compressed air system in good shape, basically with no leaks, or reduce the number of leaks as much as possible. Another fact from compressed air systems is the number that is coming from a number of surveys made in the industry where on average we are receiving feedback from the different industries that 30% of the total compressed capacity is being lost. It's being lost in leaks. So if you produce whatever, you have a 200 kilowatt compressor system, you are losing 60 kilowatts of that total power only in leaks. So that's useless for you. That's air that you cannot use. So basically there needs to be a fix there, and taking action is really worth it. Okay, so what does this new technology do for you? In a nutshell, it's sensing the sound that is around you from 2 kilohertz up to 100 kilohertz, and is mapping the sound that is detecting, which in a nutshell is compressed leaks in manufacturing sites, and overlaying that sound on a visual image, so that users, with just having a walk with the unit on their hands, can visually inspect the manufacturing site, and with a color map identify where those leaks are coming from. Okay, so you have a couple images here where you see kind of the visual representation that the user will get. You see a visual image, and on top of that, a color image that is spotting, is highlighting where the leak is coming from. Okay. So the camera, what it does is use 64 highly sensitive microphones to capture all the noise that is coming, all the sound that is coming from this factory, removing the noise that is below 20 kilohertz, that is basically noise that we are not interested in, and only taking ultrasonic frequencies. Turns out that any leak, either from a gas or a compressed air system or vacuum, they generate ultrasonic sound. Apart from other frequencies, they also generate ultrasonic sound that is, generally speaking, around 40 kilohertz frequency. So, in a nutshell, the unit is sensing, is taking all those sounds, ultrasonic sounds coming from the factory, and through a triangulation process, showing them on the visual image, so that users can see where that leak is coming from, even from the distance. So what we are doing is moving away from traditional methods where we need to really inspect linearly all the facility to a visual image that is 2 by 2, that covers a larger area. We can even detect multiple leaks in a single image from distances up to 100 meters away. So it's a completely different story. It's a completely new solution that will save time of those people involved in maintaining compressor systems as well as gases and vacuum systems in their facilities. The estimation is that it takes 1/10 of your time to do what you were doing before without this technology. So savings in terms of time, it's well above 10x. It's not only detection that this unit is helping us with, but also with reporting. Once you detect a leak, you need to document the leak so that you fix it later on. You create a work order and someone goes there to fix that leak. Well, that is also being semi-automated with this unit, where you just take a picture and the actual unit gives you the estimation in terms of liters per minute, the flow that you are losing through that leak. With a single click and giving just some information about the cost of that compressed air or that gas for you, the electricity cost basically to generate that air, it gives you the economic estimation, the cost estimation for each and every leak. So you come up with a report where you have all the leaks perfectly documented, listed, and not only that, but also you have for each and every leak the flow estimation in terms of liters per minute that you're losing, and the cost estimation for those leaks, so that you really have the decision at your fingertips. It's really easy for you to make the appropriate decisions in a matter of minutes to go for the leaks that you need to repair first. So, benefits that brings to you. We have mentioned already a few. First one is the ease of use. There is no training required. So we are all used to use our digital cameras in our mobile phone, right? So that's all that you need, basically. You just need to take good pictures, just move around, take a picture, and that's it, because the interface is quite simple. It's really easy to use. Anyone in your maintenance team can perform those measurements and that maintenance. So really easy. A lot of savings on that front. In terms of the way we are represented and documented, it's really visual. So that's also an advantage. We are used to consume visual information. So if we use a visual system and we document through images the work that we have done, it's going to be more intuitive for everyone. So whenever I have to present my actions, my maintenance actions to management, or just to, in a meeting, evaluate what to do with those leaks, it's quite straightforward and much more immediate to have a picture apart from the information. So that's really helpful. I already mentioned that we can detect leaks up to 100 meters so far away. So the detection from the distance is also one particular benefit, particularly knowing that in some cases we cannot reach dangerous areas or ducts that are really far, on the ceiling, or places that we cannot reach otherwise. So we can just, from the floor, from the distance, from the safe distance, actually, we can just focus our image, take the picture, and that's it. Time savings, I already mentioned that. That's probably one of the main benefits we get. Of course, it has to work in noisy environments. Every manufacturing site has a lot of noise, and that background noise is interfering our capacity to detect the leaks, because we are also using noise, sound, to detect the leaks. The camera just gets rid of the noise that we have on our manufacturing side, and focuses only on the ultrasonic part of the spectrum. In that part of the spectrum, we will only find leaks. So it's kind of entering a world where we are seeing things that we can only see with the camera, okay? And with no interference from any source. Increased efficiency, of course, it helps in detecting all the leaks much faster. Leak quantification, so if we compare this method to previous methods where we just heard the sound that the leaks were emitting, so we were very limited. We knew that, a higher sound will probably mean that this leak is really high, but there's no way to quantify that. With this unit, we have a quantification where it's giving us the exact amount of liters per minute that we are losing, that we are leaking through that hole or whatever defect we have. And easy documentation. That's, of course, something that I already mentioned. Really straightforward, easy to document all the leaks, because it's just a matter of taking pictures, go to your desk, and automatically generate a report with all the pictures that you found, that you documented, and as well as all the cost estimations that the camera is doing for us. So some application examples that we can mention, just to name a few, because we could spend a lot of time here going over all the examples that we have. Here you have a compressor drop in a manufacturing site. That's the way you will see, in general, a leak. It's really a really focused location of emitting noise. That means that there is a leak there. So you see that there is no more color on your image other than the specific point where you have the leak. So really straightforward. Another example in joints, whatever, you need to couple different ducts. In those cases is where you are more likely to find leaks. So this is one example in your compressor system in this case. Valves, all kind of pneumatic valve that you are using is also subject to having leaks. Of course, we can detect them with the unit. Leaks that are kind of hidden, the only thing that you need is, you don't even need line of sight with the actual leak. You can detect in sounds, the sound is going in a line, but if there is an obstacle between yourself and the leak, the sound will get its way surrounding that obstacle. So even with hidden leaks where you don't have direct line of sight, this is having a benefit, a clear benefit for the user. Now moving from compressed air leaks to gas leaks in general, here we have natural gas. Any industrial gas that we are using can be detected, so principles apply the same. You just go and inspect your system. Natural gas is, of course, in this case, is not a matter of cost efficiency. It's a matter of safety, which is even more important. If you have a natural gas leak, you'd better locate it and fix it, because, as you know, it can be explosive. It can be, you can run into some safety situations. The same applies to other gases, hydrogen, in this case, nitrogen, that is heavily used in certain industries. Here you have the same kind of situation where you clearly see where the leak is. Ammonia, again, a hazardous situation where it's, you can run into serious health issues if you have ammonia leaks. Argon, and so on and so forth. We can present many more cases. In this case, just to depict the fact that we can detect leaks really far away. This is an example where you are detecting, this is probably like 40 meters apart, or a little less than that, probably 30, but really far away. So that's another benefit. And then, so that's it relates to compressor systems. Just to show you the unit working, we have one unit here. You can see that is, quite integrated solution with the display, 17-inch display, touch display. You see here. This is the sensor matrix where we have the 64 microphones and the visual camera. So everything that we need to do is just go point to where we believe there is a leak. Of course, there is no compressor system here, no gas system that I can show you. But what I have done is generate a 20 kilohertz sine frequency, a pure tone, with my cell phone that is over there. So the only thing I need to do is go here to the frequency spectrum and get this square that you see here. This is like a filter. Actually, it's a filter. You just move it down just to cover the area where you see that there are spikes, which is around the 20 kilohertz band. Okay? So you see that the camera is detecting the leak. It's not detecting any other noise. Okay? We have noise all over the place, including my voice. It's not interfering in the detection. It's just showing the actual leak that is coming from my cell phone, in this case, okay? Because I'm simulating it. It's a 20 kilohertz signal. There's no 20 kilohertz signal here, or no signal over 20 kilohertz. And this is the typical situation that we are going to be facing in a manufacturing site, okay? So that's as simple as that. So once I have it, I will just push this green button, press it, wait 1 minute, and then I have the actual severity here. It's telling me that it's 3/10 severity, so it's not that important. And the distance is almost 1 meter far away in this case. It's pretty close. Then I can document it, and then once I have documented it, I can save it, and that's ready. I have it in my internal memory, ready for me to go to my laptop and generate the report with the cost estimation. Okay? So this is as far as compressed air, gases, vacuum system, leaks are concerned. So if with this camera we have a secondary application, there is a second application that this camera is useful for, which is electrical maintenance. In this case, we are talking about partial discharges. Partial discharge is an event that happens in medium to high voltage systems. Whenever there is a discharge, instead of between two electrodes, in that case would be an arc discharge. Partial discharge it does not require two electrodes. It's enough to have only one. So if the energy system, if the energy is high enough, that is the case in medium and high voltage systems, then a single electrode is enough to electrify the air around it, even some surfaces around it. So isolators, things like that, can become conductors, at high voltages. So it turns out that these partial discharges, or PD, they also emit ultrasound frequencies. They also emit sound in ultrasound frequencies. Okay, so in order to prevent further damages in electrical systems, generally speaking, those discharges are damaging thermally and mechanically the different electrical systems, isolators in particular, transformers, bus bars, different systems. In order to avoid severe breakdown of those systems, we need to perform preventive maintenance on those as well, which is basically go with the camera, inspect the system, looking for partial discharges. Okay. Once we identify a point where we have a partial discharge, we need to, in this case, not quantify it, but qualify it, because there are different types of partial discharges. There are a couple types that are really concerning. One is surface discharges, and the other are void or internal discharges. Those discharges can eventually damage my electrical system, and in which case we can eventually have a substantial breakdown in our electrical system, which is something, of course, that we need to avoid. So as you can see, partial discharges emit emit sound in multiple frequencies, including ultrasound frequencies. Actually, the highest energy that they emit is in ultrasound. So we can use the same technology to detect partial discharges, in which cases we will have situations like this one, okay, where we see, again from the distance, a point where we have a partial discharge. In this case, the unit not only identifies the point where that partial discharge is coming from, but also is telling us what type of partial discharge it is, okay? So that we have the complete information that we need to evaluate whether or not that partial discharge is important for us, and something should be made to correct it, or if it's a corona or it's another kind of partial discharge that is not so concerning, just keep an eye on it to make sure that it does not get worse. So that's all from my side. As a summary from today's presentation, we presented a really breakthrough innovation that is presenting a new way to detect leaks in compressor system, gas leaks, and vacuum leaks with no training required from the distance, really easily, easy documentation, and so on. As well as a solution for partial discharge detection and qualification. Okay, everything with the performance, reliability, as always, of Fluke products. So thank you very much. If you have any other question, I will be around. Please feel free to reach out to me. Otherwise, you also can go to fluke.com/ii900 to get further information of this unit. All right. Thank you very much.